Hello students, welcome to the Electronics is YouTube channel. Like, share and subscribe the channel for the upcoming videos. So in this video, we are talking about the M1 passing package questions which you have to definitely practice in order to get the good marks in your upcoming M1 examination. So coming to module 1. So in module 1, so you need to learn this derivation with the usual notations. Prove that tan phi is equal to r into dr by d theta, and so this reciprocal of this, so anything they can give. So this is the important 7 mark question asked in your examination for sure, and it is fixed question. So if P is perpendicular from the pole on the tangent, then show that 1 by P square is equal to 1 by R square plus 1 divided by R power 4 into dr by d theta the whole square. So this is also very important question, so which will be coming for your examination for 7 marks. So these two questions, how they are asking, so on referring the previous year papers, so I analyze that. So 1A they are asking this question, or 2A this is asked. So among these two questions, one question is fixed, so both the questions can come. So with the usual notation, so if you want to be on a safer side, you practice more on this first question, whatever I have told. So those are willing to pass the examination. So first question is very important compared to the second question. Okay. So this is very important from the module 1. So coming to the problems part. So they will be giving you two angles. So two angles, they will be giving you two curves. So you have to find the angle between the two curves. So if you are getting theta as 90 degree, then you call that. So see, so if you are getting theta as 90 degree, or theta is, then it is called as orthogonal condition. So you need to use the same, this tan phi is equal to r into dr by d theta. So applying log on both sides. So compare, substitute wherever you get. So with r into dr, so you have to find out the angle. But first, you have to take the first curve. You need to differentiate with respect to theta. Then you have to take the second curve. You need to differentiate with respect to theta. So either use tan phi mod of tan phi 1 minus tan phi 2, or else mod of phi 1 minus phi 2, then find out the value. So these three questions are important for the examination. So if you know the basic differentiation, so it's the same procedure, standard procedure is there to solve this problem. So next, find the pedal equation. So this is very important to find out the pedal equation problems. So they will be giving you one question. So r is equal to a into 1 minus cos theta. So there is one equation for the pedal equation which you have to remember and substitute there. So you will be getting the required pedal equation. So r is equal to a into 1 minus cos theta. So the second question is r to the power of m is equal to a to the power of m into cos m theta plus sin m theta. So practice on the pedal equation. So there is one standard procedure which you are supposed to follow for all the problems. So if you know the differentiation, so learn. So before solving any question, you should be having an ideology of how to draw, how to uh, solve trigonometry, differentiation, integration before solving. Basic knowledge of differentiation, integration, and trigonometry you should be knowing. So show that the radius of curvature at any point of a cycloid. So they will be giving you two curves, that is x is equal to a, so a into theta, so where theta is equal to sine theta. So y is equal to a into 1 minus cos theta is equal to 4a cos theta by 2. So 4a cos theta by 2. So next, they have given you. So based on radius of curvature also, there is one problem which is very important. Find the radius of curvature of the curve x cube plus y cube is equal to 3axy at what, 3a by 2 and 3a by 2. So it is 3a by 2, or so yeah, 3a by 2 and 3a by 2. So you have to find out the radius of curvature concept. So to summarize in module 1, so you should know the derivation of the first one, what I have told you. So in pedal equation problems, radius of curvature related basic problems, and this proving one. So it's very important, and the angle between the two curves. So if you have practiced this much in module 1, so you are able to solve the questions asked in the question paper. So coming to module 2, it is some special series and the limits. So here in the module 2, we need to solve expand e power sin x by Maclaurin series up to the term containing x to the power of 4. So you have a formula for both Maclaurin series and the Taylor series. So as I am discussing just the important questions, this is already explained in the course. So if you are anyone interested, can DM. So I will be giving you the link of the course for how to join. So you will be getting the detailed video of how to solve each and every question. So in Maclaurin series and Taylor series, there is one formula. So you have to use that. Based on that, you need to differentiate, and you have to obtain, if they have given till x to the power of 4, you need to solve that problem up to x to the power of 4. Okay. So if they have given, see the question properly, if they have given till x to the power of 3, you need to solve till x to the power of 3. So till where they have asked, based on, if you are not able to solve this problem by the normal method, you have to take log, whatever the rule you need to apply, you need to apply. So y is equal to 1 root of 1 plus 2 sin x. So this is very important. So in Maclaurin series, these two problems are more repeated in your examination. Do solve the same to get the better marks. So this is the partial differentiation. So they will be giving you some u curve. So they will be differentiating you. They will be giving you this. So u is equal to f of x minus 3y comma 3y minus 4z comma 4z minus 2x. Show that 6ux plus 4uy plus 3uz is equal to 0. So use the partial differentiation concept. So in this, differentiate with respect to x, differentiate with respect to y, differentiate with respect to z. So whatever you're getting the answer, so show that this equation is equivalent to 0. So next concept that is very important in module 2 is the module 3 is the extremal problem. So the extremal problem. So examine the function f of x comma y is equal to x into y, that is 1 minus x minus y for the extreme values. So problems based on the extremal is very important for the examination. So next, so this is something very much important. So if z is equal to e raised to ax plus by into the function they have given, that is f of ax minus by, show that b into dou z by dou x plus a into dou z by dou y is equal to 2abz. So you need to differentiate the terms. So, and you need to prove this equivalent, this term equivalent is equivalent to 2abz. So you will be getting in every note. So how the procedure is and detailed classes is there in the crash course. So if you anyone willing, you can join the course. So if x plus y, if x plus z plus y is equal to u, and y plus z is equal to uv, and z is equal to uvw. So find partial derivative of x comma y comma z divided by partial derivative of u comma v comma w. Very important for the examination. So this we will be calling it as Jacobian series. So you have to use the Jacobian formula and solve. So there is one matrix. So it's very easy to solve. So if you know the procedure, everything is easy. So this is something related to limit extending to 0 tan x divided by tan x of tan x by x whole to the power of 1 by x square. See students, if you get 0 by 0 form, you have to apply the LH rule. So in the LH rule, you need to differentiate the numerator and denominator continuously so that you don't get 0 by 0 form. If you are getting 0 by 0 form, you have to differentiate the numerator and denominator separately and substitute the value of limits. So if you are getting some positive or a negative value, then you stop. But if you get 0 by 0 form, LH rule will not get satisfied. So this problems are important. So for your second module. So to summarize your module 2, you should know how to solve the problems based on Taylor series, Maclaurin series, Jacobian problem and the partial derivative, and to solve the LH rule concept to in your module 2 to score the good marks. So coming to module 3. So in module 3 is something related with your partial derivatives. So there are many methods to solve the partial derivatives or the ordinary differential equation. So we will be calling it as PDE. So there is exact solution. So many methods. Bernoulli equation we will use. We will use integral formulas. So there are many ways to solve the differential equations. So based on that, so equation separable form equation is getting reduced to this. So there will be giving questions such that, so they will be giving dx and dy. So uh, this equation and this equation can be separable. So you can differentiate and then do. If it is not, you will be using the another formula and you need to convert that equation is getting reduced to separable form and do the problem. Understood, students? So these are the questions which are very important for the examination, which is most repeated. So do practice this question. So you will be getting the answers in any kind of notes, whatever you are referring. So you will be getting. So if you want the notes you don't have, just type in the Google 21MAT11. So you get some good notes. So you can refer those. So in every book, these problems are there. So you will be getting the solution of the same. So you will be solving the problems on the linear differential equation, that is dy by dx plus y cot x is equal to cos x. So 1 plus x square into dy by dy minus dx is equal to xy into dx. So next, problems on differential equations. To solve the problems on the differential equation, so a is equal to dy by dx minus 2 by x into y square divided by x cubed. So these two problems are important from the module 3. Okay. So next comes the problems on Newton's laws of cooling. So they will be giving you the statement problem. So there's a formula for Newton's laws of cooling. So you have to use that formula. So this body is taking this much time to take this much time that copper. So these two questions are most repeated in your examination. So solve the problems based on the Newton's laws of cooling. So next, so they have given a body is at 25 degrees Celsius, whose from 100 degree to 75 is taking this many minutes. Find the temperature of the body after 3 minutes. So ಇವಾಗ 25 ಇಂದ ಸೊ ಬಾಡಿ ಟೆಂಪರೇಚರ್ ಬಂದ್ಬಿಟ್ಟು 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ 100 ಇಂದ 75 ಕೂಲ್ ಆಗೋಕ್ಕೆ 1 ಮಿನಿಟ್ ತಗೊಂತಿದೆ. ಸೊ 3 minutes ಗೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ನ್ಯೂಟನ್ಸ್ ಲಾಸ್ ಆಫ್ ಕೂಲಿಂಗ್ ಫಾರ್ಮುಲಾ ಇದೆ, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮುಲಾ. ಯೂಸ್ ದಟ್ ಅಂಡ್ ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್. So a copper ball at 80 degrees Celsius cools down to 60 degrees Celsius in 20 minutes. If the temperature being 40 degrees Celsius, what will be the temperature of the ball after 40 minutes from the original? So here they have not asked the cooling period time. They have asked the original temperature. So whatever the formula you have, ಅದರಲ್ಲಿ theta naught ಅಂತ ಇರುತ್ತೆ. So ಅದನ್ನು find out ಮಾಡಕ್ಕೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ. So solve dy by dx the whole square minus 7 into dy by dx plus 12 is equal to 0. So these are the differential equations which you need to solve. Claret's equation is very important. So singular solution. So you need to find out, they will be giving you some curves. So you need to find out the singular solution. So like this only. So they will be giving you equations and you have to solve for the Claret's formula. So in the module 4, so this is also a differential equations, but here it will be homogeneous, non-homogeneous. So based on that, you will be, so these are the questions which is very much important. It is a method of variation of parameters. So more higher order differential equations you will be getting over here. D to the power of 400, d4 by dx to the power of 4. So d to the power of 300, d cubed by dx cubed. So this you need to remember, students. Okay, this is very important. So solve for the differential equations. This is also very, very important. Then method of variation of parameters. So learn. So based on module 4, you solve this many topics. So coming to module 5, it's very easiest module and you can score good marks here. So you should know the echelon form, how to solve. So echelon form ಅಂದ್ರೆ starting element first ಇರಬೇಕು, down elements ನ zero ಮಾಡ್ಕೊಂತ ಹೋಗ್ಬೇಕು until and unless you get converted into the row reduced echelon form. Use the concept of pivot and free variables and you will be solving. So rank of a matrix andre the number of non-zero rows in a matrix. So complete agi zero convert agidre adana rank consider ತಗೊಳಲ್ಲ. One element ಆದ್ರೂ if it is a non-zero, that's it. So completely zero idre matra you will not take into consideration of that row into rank. Okay, so don't get confused. One element zero ಇದೆ ಅಂತ rank ನ ಕಮ್ಮಿ ಮಾಡಬೇಡಿ ಅದಲ್ಲ. Okay, so so consistency and solve. So consistency ಅಲ್ಲಿ three types ಇದೆ. So no solution, exact solution, and there is a partial solution. So very important. So you need to learn this concept. Okay, very important for your examination. Okay, very important. So, and this will be coming for your examination. For what values of lambda and nu the system of solution will be having. So this, they will be giving this. So Gauss Seidel method, very important. Gauss elimination method, Gauss Jordan method. So for everything there is a rules so that you have to follow, and the largest eigenvalue, eigenvector. So practice on this concepts to score the good marks in 21MAT11. I wish you all the best for those who have backlogs. So there is a course going on for all the backlog subjects. Those who are very interested can take up the course. So detailed explanation, passing package, so live classes, recorded classes, everything is available. So don't forget to subscribe the channel if you are new to this channel, and meet you soon in the new video. Thank you, students.